I'm going to be going over question 3. And first, we need to understand what the problem is saying. So I'm going to read the problem. And yeah. You collected the following data for a reaction of A plus B, which gives us the product of C. Determine the order for the reaction of A and B. So if we look at A, we have values of 0.1, 0.3, and 0.1. We have B values of 0.2, 0.4, and 0.4. The rate for each one is, for the first one is 1,220, the second one is 7,320, and the third one is 2,440. So to understand what we're doing better is we need to find the reaction order for A. The reaction order tells us how the rate changes when we change the concentration of A. To do this, we are going to compare two experiments where only A changes but B stays the same. This way we know how to change the reaction due to A. So if we look at the data in experiment 1, A has 0.1 m and a reaction rate of 2,440. In experiment 2, A has a rise in molarity and increases to 0.3. The reaction rate increases the rate to 7,320, so a pretty large gap. And the concentration of B stays the same in both cases. And only A is changing, so we can figure out the rate specifically to A. So we can compare how much A has changed. The concentration went from 0.1 to 0.3 m. To find the factor by which it increased, we just are going to divide. So 0.3 divided by 0.1 equals 3. This means that the rate order increased 3 times. Now let's look at how much the rate changed. We will compare both the reaction rates. So the rate went from 2,440 to 7,320. So what we're going to do is grab the larger number, 7,320, divided by 2,440, which gives us 3. So the reaction rate also increased 3 times. Now we will determine the order. In order to do this, we will use a following rule, which is the rate change law, and that is rate change equals concentration change with an exponent of the order on top. So the rate increased by a factor of 3, and the concentration of A also increased by a factor of 3. Since 3 to the power of 1 is still 3, this means that the order reaction to A is 1. 3 exponent of 1 is 3. So our order reaction for A will be 1. I know I repeated myself, but I was just trying to understand what I was saying. So to simplify why we got that, the number 3 comes from the fact that both concentration and rate increased by 3. 3, 1 equals 3. A order is 1. And now we can do the same thing for B. So if we look at B, we have our rates, our concentrations for B. We're going to use 0.4 and 0.2. And then we are going to get that, and that's going to give us a rate of 2. And then we have the rate changes from the concentration. It went from a rate of 1,220 to 2,420. So since we have those two, we're going to divide those as well, and we get 2. Now it's the same for both of them. So they both have an order. A has a rate order of 1, and B has a rate order of 1.